Hello everyone. So we are going to talk about intercept. In the previous video, we learned about gradient, how to find gradient, and what does gradient means. So we looked at this picture before. So we have three lines over there, and they're in parallel. We say that their gradients are the same. Now, if I want to describe the line to someone else, one thing I will say is the gradient. Now, because all three lines share the same gradient, how to distinguish one from the others will be the questions. If you look at the lines, we can see that the blue, yellow, and red line, they all pass through different point on the y-axis. My y-axis and x-axis will stay in its position. So that's my what I'm going to compare it. That's our standard. So when we compare that to a fixed point, it's going to give me a more accurate location. And when the lines pass through its y-axis, we call that y-intercept or the interception point. Now, every single line could be described or could be located through gradient and y-intercept. So we use gradient and intercept to represent the line. And then in math, if you want to represent a line, we use equation to represent every point that's on the line there. And our general equation for any linear line will be y equals to mx plus c. So the m over here representing the gradient, and the c is representing the y-interception point, y-intercept. Now, in our textbook, you will see that the linear equation is represented by y equals to a plus bx. It's still the same. They just put the y-interception at the front and they put the gradient at the back. It doesn't really matter which letter do you use to represent the gradient or the interception point, but you need to remember that the gradient is always multiplied to your independent variable. Now, in our cases, we call it explanatory variable, and then our constant term, or the term without any variable, the y-intercept, is plus or is added on top of my variable term. Okay, so this could be a positive number. My I, M, and C, they can both be positive, or they could be one negative, one positive, both negative. So they could be any sign, same as A and B. Now we already in the previous video we talked about if gradient is going to be positive, how the graph will be looking like, how the graph will look like. And if the gradient is negative, how the graph looks like. So if you can't remember that, you can go back to the previous video. In this picture, we see that there are many lines crossing the same point. So unlike the previous picture we saw over here, they have the same gradient but different y-intercept, or all the lines on this graph have the same y-intercept but different gradient. So you can see that they all pass through the same point on the y-coordinate. Okay, now let's try a question. So in this question, it's giving you 2 points. One point is 0, 1, and the other point is 2, 7. So we're going to use these 2 points to show that the equation that can use to represent the linear equation is y equals to 1 plus 3x. So this is a show type of question. Remember, when we answer show type of questions, we always pretend that we don't know what is the answer. So we're using these 2 points, point 1 and point 2, to find the equation that pass through these 2 points. Okay, so in our general equation, I'm used to writing y equals to mx plus b, so y equals to mx plus c. So that's how I'm going to use to represent the generalized equation of my linear lines. So we know that the y is representing the responsive variable, x is the explanatory variable, so they will stay the same. So we don't need to use any number to replace the x and y to in our general equation. So imagine if we give x and y a meaning. For example, x could be the time and y could be the distance. Now, the distance traveled is depending on the time. Our time is always changing, so we can't use a number to replace it. We need to actually write down time, because that is why we're keeping y and x unchanged. We are not replacing them with any numbers there. Okay. To find out gradient, we're going to use that equation to find out gradient. Gradient is equals to change in y coordinate divided by the change in x coordinate. To find out the change in y, we need to use y2 take away y1, and we're going to change in x will be x2 take away x1. So y2 and x2 are from the second point, are from point 2. Y1 and x1 are from the first point, so it is coming from point 1. Now my y2 is equals to 7, y1 is equals to 1, so I will go 7 take away 1. And x2 is equals to 2, and x1 is equals to 0, so 2 take away 0. I will just write 2 over here. So on the top of the fraction, we have 6 and divide by 2, so your answer will be 3. So the gradient is equal to 3 means that m from the general equation is equal to 3. So now we need to find out what the c equals to. If you look at the graph being drawn, if our y-interception point is at 0, 1, so when x is equal to 0 or y equals to 1, and the y-interception point is the y-coordinate reading that's on the line. Because if we are talking about the x-coordinate, we know that it's going to pass through the y-axis because that's where we're looking at. If the point is on y-axis, means that the x-coordinate is always 0. So where we are looking, our c is equals to the y-coordinate of the point that is on y-axis, okay, because on the x-coordinate is always going to be 0. So from reading from the graph, we know that c is equal to 1. Then we can put our m equal to 3, c equals 1 into the general equation. We have y is equal to 3x plus 1. If we compare to the equation over here, the x terms are the same and the constant terms are the same as well. Okay, so I can rearrange it. I can put my 1 at the front and 3x at the back. So it could be rearranged to 1 plus 3x, but it's not necessary. So from these two, by finding out the gradient and intercept, we can find out the equation of the linear equation that's shown on the graph.